And welcome to the chemistry channel with Sarvat Ahmed. Today I will be discussing paper 1 multiple choice question 9701 paper 1 from May June 2021. Let's start. Which contains the largest number of hydrogen atoms? 0.1 mole of pentane. Pentane is C5H12, number of hydrogen atom 12, and this is 0.1 mole. And we know that number of hydrogen atom considered as particles, and number of particle is equal to mole into number of atoms multiplied by Avogadro constant. So in this molecule is equal to 0.10, number of atom hydrogen atom 12 into 6.02 into 10 raised power 23. This is equal to 7.22 into 10 raised power 23. 0.2 mole of but2ene C4H8. So this is 0.20 into 8 atoms into 6.02 into 10 raised power 23. This is equal to 9.63 into 10 raised power 23. 1 mole of hydrogen molecule. Hydrogen molecule has 2 atoms. So this is 1 into 2 into 6.02 into 10 raised power 23. This is 1.2 into 10 raised power 23. 6.02 into 10 raised power 23 hydrogen atom. This is hydrogen atom is equal to 6.02 into 10 raised power 23 into 1 is equal to 6.02 into 10 raised power 23. So the largest number of hydrogen atoms will be 9.63 into 10 raised power 23. So B option is correct. In which pair of species do both species have only one unpaired electrons? Unpaired electrons. Argon plus argon is 18, and if positive one, this is 17. Carbon minus 1, this is 6, this is 7. And boron 5, this is also 5. Titanium atomic number is 22, and here atomic number is, after losing one electron, this will be equal to 21. Iron fluorine, this is 9, and it is also 9. And gallium 31, this is atom, so it is 31. Selenium minus 1, it is 34. 1 electron gained, so it will become 35. And silicon is 28. 1 electron gains, 29. So which have only one unpaired p electrons? Unpaired p electron, six and 7. not only one unpaired orgon. This is P. This is incorrect, and 5 is one S2 and 2S2 and 2P1. But titanium does not have one unpaired p electrons. This is also incorrect. Fluorine only one unpaired p electron, only one unpaired p electrons. P1. Titanium, let's wait. If 22, titanium is 22, 1s2, 2s2, 2p6 and 3s2, 3p, 4, 6, 10, 3p6, 3d10, 4, 6, 10, 10 to 12, 4, 6, 18, 18 and d1. So this is titanium positive, 1s2, 2s2, 2p6, 3s2, 3p6 and 3d1 and 4s2. So this is also incorrect. So next is C, fluorine and gallium. 1s fluorine is 1s2, 2s2, 2p, 1s2, 2s2, 2p6 and 3s610. So this is 9. So p5. This has only one unpaired p electron. Unpaired p electron. One unpaired. And gallium. Gallium is 31. 1s2, 1s2, 2s2, 2p6, 3s2, 3p6, 3d10, and 3d10, 4s2, 4p1. This is 31 and 4p1. Only one unpaired p electrons. So this is only one unpaired p electron. So this is correct. C option is correct. So selenium is incorrect, 35. This is 35. So it is present in group It is present in group 6, so it does not have one unpaired p electrons, and silicon -1 is 14, so 29, so it also does not have unpaired electrons. Like silicon, let's try selenium. 1s2, 2s2, 2p6, 3s2, 3p6, 3d10, 4s2 and 4p4. So this is also p has so 2 unpaired electrons, so this is incorrect. And silicon is 14, -1, 1s2, 2s2, 2p6, 3s2 and 3p3. So this is -1, gain 1 electron to 3p1, 1 3 unpaired electrons. So C option is correct. Phosphorus forms 2 chlorides, phosphorus 3 chlorides, PCl3 is a covalent liquid. Phosphorus 5 chloride is an ionic solid. One of the ion is PCl4. What is the shape of PCl3 and PCl4? PCl3 Cl, this is pyramidal, and PCl4, this is tetrahedral. So this is pyramidal and square plane are not correct. A option is, so pyramidal and tetrahedral is correct option. Delta HF is standard enthalpy of formation of methane. Delta H2 is a standard enthalpy of combustion, and delta H3 is the standard enthalpy of combustion of hydrogen. Which expression is equivalent to delta Hc? So this is carbon plus hydrogen. Solid state, gaseous state, so 2H2, this is delta HF or delta H1, this is delta H combustion, delta HC or delta H3, this is delta H2 and this is delta H3. Delta Hc is combustion of hydrogen, and this is delta H1 is the standard enthalpy change of formation of methane. Which expression is equivalent to delta Hc? Delta Hc. Delta Hc is equal to delta H2 this is delta Hc is equal to delta H2 plus delta H3 and minus delta H1. Delta H1 delta H3 is into 2. So delta H1 minus delta H2 plus delta H3. This is incorrect. Delta H1 minus delta 2 delta H3 minus delta H incorrect. H2 minus delta H3 plus delta H1. So this is again incorrect. So this is correct. Delta Hc. Delta Hc combustion is so this is correct. Delta H2 plus delta 2 delta H3 minus delta H1. So this option is correct. The diagram shows the Boltzmann distribution for the same gas at two different temperature T1 and T2. What is plotted on the y-axis and which line represents the higher temperature? Y is the number of molecule and which is higher temperature? T2 is higher temperature. So number of molecules and T2, this is incorrect, correct, this is correct. So B option is correct. So this is not molecular energy, these are the number of molecules spread on this curve, under this curve. So not, this is number of molecules at higher and lower temperature. T1 is the lower temperature and T2 is the higher temperature. What is the minimum mass of oxygen required to ensure the complete combustion of 12 dm cube of propane measured under the room conditions? Number of mole of propane is equal to 12 divided by 24 dm cube. This is equal to 0.5 mole. Now we know the chemical equation C3H8 plus oxygen to form CO2 plus water. This is 4H2O and this is 3 CO2, 3 to the 6 and 5 oxygen molecule. What mass, minimum mass of oxygen? So 1:5, 0.5 mole ratio x. So cross multiply and mole of oxygen is equal to 2.5 and mass of oxygen is equal to mole into mR. Mole is 2.5 multiplied by 32, which is equal to 80 grams. So this option is correct. Why is the first ionization energy of oxygen less than that of nitrogen? Oxygen less than that of nitrogen. Oxygen 8 is equal to 1s2, 2s2, 2p4, and this shell is, while nitrogen is 7, 1s2, 2s2 and 2p3. Half. This is partially filled and this is half filled. Half filled orbital is stable and more energy is required to remove the electron. While this is partially filled, so due to repulsion of two electrons in one orbital, it is less energy is required to remove this electron from the p orbital. The nitrogen atom has its outer electron in different subshells. Not different subshells. 2p3 valence shell electrons. So this is incorrect. The nuclear charge on the oxygen atom is greater than that of the nitrogen atom. Nuclear charge on the oxygen atom is greater than that of on the nitrogen atom. Nuclear charge does not affect the first ionization energy. So this is incorrect. The oxygen atom has a pair of electrons in 1p orbitals that repel one another. So this must be correct because over here pair of electrons in 1p orbital that repel one another. So this is here in oxygen. In case of oxygen, less energy is required to remove the electron from its valence shell. There is more shielding in an oxygen atom, not more shielding because same shells, nitrogen and oxygen are present in the same period and has same number of shells, so same shielding effect. So this is incorrect. Which gas would behave most like an ideal gas under room conditions? Under room condition, ideal gas has insignificant volume, and insignificant force of attraction between the particles. So helium behave most like an ideal gas. Nitrogen is 28 more mR, ammonia is deviate more NH3, 17 krypton. So helium is the best option. When hydrogen iodide is reacted with concentrated sulfuric acid, several reactions occur, including this H2S, water, and I2, which row gives the change in oxidation number of iodine and of sulfur in this reaction. This is -1 and over here 0. -1 and 0. The change is +1. And sulfur +6 and over here -2. So change is +6 and then -2, +6 to 0 and then -2. So this is equal to -8. The change is -8. So +1 and -8. -1 not correct, -1 not correct, +1 correct, -6 incorrect. So +1 correct, -8 correct. D option is correct option. The diagram represents the Haber process for the manufacture of ammonia from nitrogen and hydrogen. Heat exchanger. What is the purpose of the heat exchanger? Heat exchanger to cool the incoming gas mixture to avoid overheating the catalyst. Now this is not correct. Not heat exchanger does not cool the incoming gas mixture to avoid the overheated. To cool the reaction products and separate the ammonia from unused nitrogen. No heat exchanger, not cool down. So this the heat exchanger is used to warm the incoming gases. So warm the incoming gas mixture and shift the equilibrium to give more ammonia. No, this is not correct. To warm the incoming gas mixture and speed up the reaction. So this is correct. Which statement about catalyst is correct? They change the reaction pathways by increasing the by lowering the activation energy. So this is incorrect. They increase the rate of reaction by lowering the enthalpy change, not lowering the enthalpy change, lowering the activation energy. They increase the number of particles that have sufficient energy to react. This must be correct. They increase the number of particles that have sufficient energy to react. C option is heterogeneous catalysts are in the same state, not in same state, are in different state. So this is also incorrect. Element X is in period 3. Element X forms a solid oxide Y. Y reacts with hot concentrated hydrochloric acid. Y reacts with hot sodium hydroxide. So it is the type of oxide which react both with hydrochloric acid as well as with hot aqueous sodium hydroxide to form a compound in which X is part of an anion. How many peak? So this is the amphoteric oxide which react with both sodium hydroxide and concentrated which react with both sodium hydroxide and HCl. Hydroxide to form a compound in X is a part of an anion. Yes, X is part of an anion. X is in period 3, element X forms the solid of Y. How many p electron does one atom of X have in its outer shell? If it is period 3, so this element has 3 electrons in many p electrons, 3 p electrons. So it is present in group 13. How many p electron does one atom of X have in its valence shell? So it has 3 p electrons in its valence shell. So D must be correct. Why react with hot concentrated hydrochloric acid? Why react with hot aqueous sodium hydroxide to form a compound in which X is part of an anion? Solid oxide Y. To form a compound in which X, yes, sorry, this is not amphoteric oxide, this is X forms a solid oxide Y. Y react with hot concentrated hydrochloric acid. Y reacts with hot aqueous sodium hydroxide to form a compound in which X is part of an anion. So D option is correct option. Element X is in period 3, element X forms a solid Y. Both, this is amphoteric oxide, yes, this is amphoteric oxide which react with both sodium hydroxide and alkali. And how many p electron does one atom of X have its outer shell? How many p electrons? So this is aluminium oxide which can react with sodium hydroxide as well HCl. So its electronic configuration is 1s2, 2s2, 2p6, 3s2, 3p1. So the valence shell has 3 electrons. So that's why D option is correct. Question number 13. The gaseous products of heating mixture is mixture of calcium hydroxide and NH4Cl are passed through solid calcium oxide. A single gaseous product W is collected. Calcium hydroxide and calcium hydroxide plus NH4Cl to form CaCl2 plus ammonia plus water. So only gaseous mixture. A single gaseous product W is collected. So this is ammonia is in the form of gas. So this is W. A sample of W reacts with chlorine NH3 plus Cl2 to produce two gaseous X and Y. So this is two gaseous gases X and Y. This is HCl and N2. Two HCl and two 3HCl so these are the two gases HCl and N2 2NH3 so this is 6 and this is 3 so a W react with chlorine to produce X and Y. This is X and this is Y. This is X and this is Y. X is an element. Yes, X is an element. This will be X. Sorry. This is X and this is Y. X is an element and Y is acidic. This is acidic gas. Y reacts with W to produce Z. Y react with W. W is this ammonia. NH3 plus HCl to form NH4Cl. So this is Z. What are X and Z? X would be nitrogen and Z would be ammonium chloride. B option is correct. If question number 14, Q is a mixture of group 2 oxide and group 2 sulfate. Q contains equal amount of the two compounds, group 2 oxide and group 2 sulfate. Q is shaken with water and resulting mixture filtered, a solid residue is obtained. Q is shaken with water, this is group 2, and solid residue is obtained. There is no reaction when the solid residue is shaken with HCl. No reaction with HCl. Shaking the filtrate with H2SO4 produces a white precipitate. So Q is a mixture of group 2 oxide and group 2 sulfate. Q contains equal amount of two compounds. Q is shaken with water and the resulting mixture is filtered. A solid residues. Q is shaken with water. Barium oxide is barium hydroxide and solid residue is obtained. There is no reaction when the solid residue is shaken with HCl. BaSO4 is solid, MgSO4 aqueous, BaO in water is aqueous. This is solid, so this option is incorrect. magnesium oxide aqueous magnesium oxide. So resulting solid residue is resulting mixture filtered. Q is shaken with water. Yes, Q contains equal amounts of two compounds, group 2 and barium oxide and barium sulfate. So barium sulfate is barium oxide plus barium sulfate. When react with water, barium hydroxide plus barium sulfate. There is no reaction when the solid residue is shaken with HCl. Yes, there is no reaction with BaSO4 plus HCl. There is no reaction when shaken with HCl. Both shaking with filtrate. This is filtrate aqueous. This is filtrate, and when this filtrate is shaking with sulfuric acid, barium sulfate is produced plus water. So this is solid. White precipitate of barium. Barium sulfate, magnesium sulfate does not form white precipitate like this. Barium oxide plus magnesium sulfate, both are soluble, so there is no reaction, no residue with this mixture. So this is incorrect. Magnesium oxide and magnesium oxide is solid, so both are form precipitates. No reaction with water. No reaction with water because both are insoluble. Magnesium oxide and magnesium sulfate. Magnesium oxide both are. This is solid. Magnesium oxide does react with HCl to form magnesium chloride. But here, when the solid residue is shaken with HCl, there is no reaction. So it is also not correct. B option is correct. Which substance will not be a product of the thermal decomposition of hydrated magnesium nitrate? Magnesium nitrate hydrated NO3 twice dot H2O to form MgO plus NO2 plus oxygen gas plus water. So this is not the product of dinitrogen N2O. Magnesium oxide is the product, oxygen is the product, steam is the product. So this is incorrect. This is incorrect because N2O dinitrogen monoxide will not be a product of thermal decomposition of hydrated magnesium nitrate. So this is correct. A 5 centimeter cube sample of 0.05 sodium chloride is mixed with 5 centimeter cube of 0. Potassium iodide. Sodium chloride plus potassium iodide and of acidified 0. Silver nitrate is then added, followed by concentrated ammonia plus ammonia NH3 to form silver iodide plus KCl plus NaNO3. So silver iodide form a yellow precipitate which is insoluble in ammonia, concentrated ammonia. Silver iodide is insoluble. It is insoluble. First of all, like this is the reaction, I think so. This is reaction AgI to AgI plus NaNO3 plus KCl. And if in this mixture, when ammonia is added, silver iodide cannot dissolve, so yellow precipitate will remain insoluble. So the yellow precipitate is formed. So C option is correct. Green precipitate for AgBr, white precipitate AgCl, and yellow precipitate AgI. AgCl is soluble in dilute ammonia. AgBr is soluble in concentrated ammonia. So yellow precipitate is not soluble in concentrated ammonia. So this is, so that's why A, B and D is incorrect. The volatility of group 17 elements chlorine, bromine and iodine decreases down the group. What is the responsible for this trend? Number of electrons. So down the group, chlorine, bromine and iodine. Down the group, number of shells are increased. So number of shells with number of electrons also increased. So when number of electrons increased, so there are more number of electrons, there are more van der Waals forces, which causes volatility decreases. So bond length does not affect bond strength, not electronegativity of the halogen atom does not affect number of electrons in the halogen atom. Number of electrons affect the volatility of the group 17 elements. So more the number of electrons, less the volatility. More the number of electrons, less the volatility. Less the volatility. So D option is correct. Acid rain is dilute solution of sulfuric acid. Which pollutant also contributes to the formation of acid rain? Carbon monoxide does not also contribute. Carbon dioxide also does not. Nitrogen dioxide. So this option is correct because NO2, H2O, HNO3. Hydrocarbon does not. C option A. R is an oxide of period 3 element. T, 5 gram of R contains 5 gram of R contains 2.50 gram of T. So OR ratio T, if 5 gram minus 2.50 is equal to 2.50. If 2 is 2.50, so R must be 2.50 because total compound is 5. So the T R is an oxide of 3 group period 3 element T. So this is oxygen. So the oxygen is 32 mR over here X. 2.50 into 32, 2.50 equal to X. So this would be this mass over mass. So we can identify the AR of the compound. So oxygen is in the presence of oxygen gas. So this sulfur is the correct option. Bromoethane reacts with cyanide ions producing propanenitrile. Bromoethane CH3CH2Br react lone pair of electrons CH3HH. The lone pair of electrons on C of cyanide ion attacks the carbon atom of CBr. Yes, Cn, the lone pair of electrons on C. So this is lone pair of electrons attacks on the carbon atom of the CBr. Yes, this is correct. This is prime, this is SN2 mechanism. So this option is correct. Lone pair of electrons on C of Cn attacks the carbocation formed when the C bar breaks. No, does not break. So this both reaction takes place in one step. So that's why it is not correct. The lone pair of electrons on nitrogen. Lone pair of electrons not on nitrogen. C of cyanide attacks the carbon atom of the CBr. So that's why it's correct. Incorrect. The lone pair of electrons on nitrogen of Cn attacks the carbocation formed when the CBr. So it occurs only in one reaction, not nitrogen. This is also incorrect. This is also incorrect. So D option is incorrect.